Welcome to Cincinnati. I'm Professor Carlton Brett from the University of Cincinnati. As you know, Cincinnati has a long history. It was once called Porkopolis, from the famous pig production plants that were here in the city. It's the home of Procter & Gamble and lots of other things, but in fact, what you don't know perhaps is that Cincinnati is famous around the world by geologists. And geologists know the name Cincinnati and Cincinnatian for the rocks that form the very foundation of our city. If you think about it the way I do, I often tell my students the very hills that form Cincinnati are the result of shells and small animal colonies that lived almost 500 million years ago on a seafloor when this area was utterly different from what it is today, when Cincinnati was covered by a subtropical sea, when we were in the southern hemisphere, when life as we know it wasn't yet on land. The very first inklings of greening on the land way over in what would today be New York State and so on might have been there, but no forests, no flowers, no animals on land. Out to sea, there were many interesting animals living, and their shells and skeletons accumulated in great numbers, forming the beds that today are Cincinnati. The stratigraphic period in Cincinnati is the late part of the Ordovician period, which is often called the Cincinnatian, from around 450 to about 443 million years ago, a time when there were no fish, at least in this area, and very few fish that had jaws, and when the sea was covering not just Cincinnati, but many, many other areas of North America. The climate was warm subtropical. We were south of the equator by about 25 degrees. In the time since then, and remember that is almost 500 million years ago, 450 million years, because of continental drift, the entire continent of North America has migrated northward and rotated clockwise, and it has basically come to its present position over the last 450 million years from a subtropical location. And that's all powered by the movements of huge areas of the Earth's surface called plates. And these plates are chunks of rock that start at the mid-ocean ridges, where rock is actively being added to by injecting magmas of volcanic rock called basalt, which is then tearing apart and splitting to form two plates that migrate apart from one another. North America is attached to one of these plates. Now, the Cincinnati Arch is a dominant feature of the local geology. It was a gentle bowing of the crust. It's not a very impressive feature in terms of topography, but it was just enough, probably less than 1/10 of a degree upward tilt in the center, to expose younger rocks to erosion at the center of the arch. And this then, over the last, say, 300 million years, has stripped away rock from the center, which was the high point of this arch feature, and has eroded down to older rocks. The reason that it's arched is that basically, during the formation of the Appalachian Mountains, there was a huge collision that involved Africa pushing up against North America, or what is parts of North America today, and this area underwent a great deal of compression, and out in the area away from the mountains, there was a bulging up of the crust that's called an arch, and this arch has been eroded since then. The fossils that are found in the Cincinnati area are amazingly rich and diverse. There are lots of shellfish called brachiopods, which I didn't bring one, but those, and some things called bryozoans, which are moss animals that formed a colony. Probably the most famous fossils in the Cincinnati area, however, are trilobites. And these were a kind of arthropod, that's an animal that's related to crustaceans and shrimps and lobsters, crabs, which are basically segmented and had a tail end, a head end with two eyes. And this is an example of Isotylus, which is our state fossil. Ohio's state invertebrate fossil is a trilobite. Now, this is a small individual. These small animals were crawling scavengers and soft-bodied predators that fed on worms and so on. but they could get much larger. The largest ones known are of this type, this genus called Isotylus, and they can be up almost a yard or a meter long. The big predators of the time were things called cephalopods. Here's an example of one of these. You can see it's got a chambered shell, and these are the chambers filled in with sediment with a tube running down the center. And these are a long sort of, say, segmented looking shell with a body chamber in which the animal lived. And these are related to the modern nautilus, which is a cephalopod. Cephalopods include squids, octopus, some of the most intelligent and largest invertebrate animals. And you can see how we can link this modern nautilus, this is what its outside of its shell looks like here, to the fossil, because you see the internal segmentation inside, the chambering, and there is a tube that runs back through the shell as well. The dinosaurs didn't come along for a couple 100 million years after this time, and they are found in rock deposits somewhere around 220 million years ago, or in the early part of the Mesozoic era. Now, perhaps those, obviously the time existed here, there was a Mesozoic time here, and there may have been dinosaurs here as well, but if there were any sediments here from that time, they've been eroded away. And in fact, probably during the time when dinosaurs lived, this entire region was undergoing erosion because it had been uplifted by the Appalachian mountain building. You see, the same thing that produced the Cincinnati Arch. And instead of having any deposits accumulating, we're simply stripping the sediments away, moving them on down, for example, down to the ancestral Mississippi River and out to sea. So for a while, at least, there was no record. In fact, there was almost no record all the way up almost to the modern, to the time of the glaciers. So we're missing in this area more than 450 million years of record. It's been either never deposited or eroded away. Thanks very much for hearing me out. There's a lot of exciting geology in our area. It's really a natural laboratory for myself and my students. I do a lot of field trips in the area, and my greatest joy is getting people to understand the wonderful heritage that we have here in the Cincinnati region and the spectacular fossils, rocks, other features, geologic features that are a part of our natural heritage here. So I love living in Cincinnati area. I'm its biggest booster. I didn't come from this area, but I did in fact come from New England. But I love the Cincinnati tri-state area for its geology, for its people, for its culture, and the general beauty of the land in this region that a lot of people just are unaware of. So thank you, and I hope you'll enjoy your Cincinnati region.